Good morning, everybody. I'm glad to see so many faces after the long party yesterday. So I'm going to talk about IPv6, the deployment that we have done in a very short thing, and issues that we have seen during the rollout, both from a technical point of view on the software code base, the hardware, and of course what issues we have seen once we have gone beyond the AS borderline, peering at the exchanges, setting up peering sessions with other ISPs and stuff like that. So let's start out with section 1, a short, brief overview about the key messages of the day. We see that there's a global movement for IPv6. Several regions of the world are demanding that. Even our customers in several regions, like the research networks that are connected with us, or the mobile and voice carriers, are demanding that. And you've seen it in about a few presentations yesterday when there was the Erin report that over the last few years the demand for IPv6 allocation is growing, and not in a linear manner, more in an exponential way. So especially in the European and the Asian region. Yeah, as I said, we have customers who are demanding that, who say, you know what, we are just prolonging the contract with you when you are able to deliver IPv4 multicast. And of course, IPv6, for IPv6, they do not mind whether it's a tunneled connection or a native one, but at least they want to see some progress from the carrier side. The vendors still lack a proper support, or not all vendors do a proper IPv6 support and things like that. So we hope that these things change in the foreseeable future. So the next thing is our own deployment in a very brief manner. Let's begin with the addressing scheme. We have received an allocation of a /21 from RIPE. This /21 we divide into several /32 chunks that we use for in-country blocks. This allows us to support IPGP aggregation, or if in the future someone comes up and say, hey, we need some confederation setup, then this addressing plan would also support confederation if it's needed. So the country blocks are getting subdivided into /40 chunks. So every pop from a certain country gets an /40, and these /40 chunks, we say the first /48 of that /40 is being used for point-to-point links for customers, like transfer networks and stuff like that. And the remaining 255 /48s are used for static customer use at that particular node. We had then we use, of course, every customer, whether it's a hosting customer or an access customer, gets an /48 unless they can document pretty well that they need more. So the only thing with the hosted customers is we say the first /64 out of that customer /48 we use for the hosting setups, point-to-point links to get to the root of the customer, and we route the rest statically to the customer's premises device. This has one big advantage, that is the abuse management. Let's say a customer is just using the transfer network for something else they could do some shaping stuff or whatsoever, and just rewriting everything to their point-to-point link address. Then in the RIPE database, it's still documented that the transfer network belongs to the customer. So the abuse mails are directly connected, are directly sendable to the customer rather than to our abuse management desk. Reasons why we have done this addressing scheme with the /32 down to /40 and so on, and why we are using /64s on every point-to-point link, regardless what interface type it is, whether it's FastE or NBMA or broadcast media or point-to-point, it's always in /64. So that's used due to the mostly for management reasons. We want to be able to that the DNS reverse resolving is done automatically. We want to do the customer assignments automatically out of an internal database, and this is just a hassle when you have to deal with different sizes of transfer networks. So this so far for the addressing stuff. Okay, next our internal protocol is ISIS. Prior to the rollout phase, we thought, okay, it is a good idea to use multi-topology ISIS because of the advantage to be able to have different path costs for IPv4 and IPv6 once it's deployed, and of course to be able to route around devices in the core that are not yet v6 capable. This was a good thing for the rollout phase, the starting phase, and since we're completed with rolling out IPv6 in the entire core, it turned out to be a pretty nice feature still to have a different IGP metric for v6 and v4. So we're going to stick with that. We are only transporting the router loopbacks and the backbone interfaces within within ISIS. You could say, as a side note, that you would get away with having only the loopbacks in ISIS rather than loopbacks and backbone links, because ISIS doesn't rely on IP to form the adjacencies, but we wanted to do the same in IPv6 as we do in IPv4 with our ISIS setup. BGP is pretty straightforward. It is the exact same implementation as in before. We support the same local preference structure. Customers higher local pref than peers and transit. We support the same community set for our customers and peers, so they can steer where they get being announced or not. Yeah, the black holing community is something that we wanted to do, but well, during the rollout phase we didn't do it, but we want to do it, and it will be available soon. Yeah, we transport all aggregates and static routes and all the normal stuff in iBGP so far. So 6P or not, this was a question prior the rollout. Do we do 6P or do we rather go for native IPv6 on every box? Do we want to turn on MPLS or not? The point for us was that most of the core and aggregation devices are Juniper based, so we said, okay, we have a proper support there, so we rather go for native IPv6 than 6P, because 6P is, as we see, a not so nice solution, because there's a mapped IPv4 to IPv6 next hop for the BGP sessions, and well, it's nice for a rollout thing, but unless there is a proper LDP and RSVP support for MPLS traffic engineering, 6P is nothing really nice. So we said we would yeah, rather go for the real thing. That's so far from the technology side of 6PE. There's also a commercial and economical side. In the future, we may be forced to use equipment in the core, in the middle of the core, especially with the 10G stuff, that forces us to use equipment that is not yet V6 capable, just because it's so much cheaper than any other gear that we have so far. So the economics may be a driver for 6P in the future. So let's see what really happens there. Hardware that we're using is we have rolled out IPv6 onto every core device, which is an M-series Juniper thing, and to all Juniper aggregation boxes. Cisco's we didn't touch yet, but I come to that point a little bit later in detail. And to Juniper E-series we didn't roll it out yet because, yeah, I come to that point later in detail as well. So we've covered about 95% with the used hardware so far, and it works quite nice so far. Good. Next thing is the vendors. Yeah, some vendors really successfully prevent a proper rollout of V6. Let's come to the two famous ones. Juniper E-series is there's only OSPF v3 support since the last version I have seen, but no ISIS support yet, which is just operational annoying, but not a real problem. You could come up with something that it works together with the rest of the hardware, but the much more annoying fact is that Juniper is charging a premium amount of money just for the V6 license, and this is ridiculous just because, you know, V6 is not something that grants a carrier to have a license for printing money. It's just an add-on service for V4 right now. It's nothing premium. So we do not understand why Juniper is doing that, and especially for the E-series, this is annoying because so many carriers are using the E-series boxes as their DSL terminating stuff for the residential market. So there could be more DSL users having V6 right now if they wouldn't do that kind of stuff. And as a side note, it is interesting that I've seen in the newest price list from Juniper that they start charging a license fee for the M series and T series as well. So I don't know whether it's a good political thing or not, but it's up to Juniper to decide. Cisco is the next one. It's a really interesting one because there's, from an operational point of view, no common code base for different platforms that really work together. For example, for the GSRs, there's a 12 OS code which is working quite okay. Depends on what line card type you have or not. But 12 OS is not having V6 and multi-topology ISIS for the 7.5ers or 7.2 models. So for these models, you need to go to 12.2S if you want to multi-topology ISIS and V6 and all the features that are interesting from a carrier point of view. So this is just from operational side annoying, but it would be nice to have a common base because you would assume that you have the common base of bugs as well. Oh, no, challenges, sorry. But still the 12.2S train has severe bugs within the Ceph code. We have switched on the check Ceph stuff, and we have seen that while the V6 stuff doesn't have mismatches, the V4 stuff has many Ceph mismatches, so Ceph doesn't really work properly with the 12.2S code. And the latest code I've seen was 12.225S4 or so. So it's really hard to choose an iOS code for the 7.5 models that is really working well for IPv4 and IPv6. So I'm sorry, this should be not an issue in these days anymore. Ceph is around for quite a while, but you know. And there's an interesting, infamous ghost route bug which has been accepted by Cisco last year when we found out with Global Crossing that there is this bug, and it was for the first time reproducible, but up to now there's no fix here yet. So that's for the two famous vendors. I picked some others randomly, so this is no personal or company preference thing. It's just random where I know some people, Alcatel and Telabs. The key message there is that both do not have an IPv6 stack yet. Both do not have multi-topology ISIs yet. And the timelines for both are slightly differing. While Telabs promised to have out something end of this year, maybe Q1 next year, Alcatel is still far off to have something in the V6 and IS multi-topology world. So the key message here is, again, we are in 2005 and IPv6 is around for about 10 years now, so you would assume that any vendor that wants to sell new gear today supports V6 properly, but in fact they don't. So far for our rollout experience with the hardware and with the software stuff. Now let's go when we go beyond our own AS borders. So once we were starting out V6 in Europe, going to the exchanges there first, and they're pretty straightforward that IPv4 unicast and IPv6 unicast were residing on the same LAN or VLAN, and they are all using production IPv6 space that is especially reserved for internet exchange points. So we assumed that would be the same in the States here, but we have been proven wrong. Yeah, some of the exchanges here still use experimental space or still using a separate VLAN for IPv4 and IPv6, and I've approached them and say, listen, why do you divide these two protocols? They do not harm any, and it has been proven around the world that you could have both on one and the same VLAN, but still they didn't change it, and the result of that is that a carrier is forced to have the investment for an extra interface, and we all know that the budgets for everything are pretty low, and you have to go to your controlling department to say, look, I need an interface for this and that, and if you just come up with, I want to peer IPv6, therefore I need to buy a gigi interface for about $11,000, your controlling departments will probably say, no, thanks. Other things we have seen is the use of non-productional space. Again, I've approached the IXPs providers and listen, why don't you go for the production space? There is a reserved space, and but they said, well, 3FFE space is still working, why should I? Well, the reasons are on hand. There might be problems with DNS reverse resolving, and of course 3FFE space is planned to go away next year on the 6th of June. 6th. And yeah, and by that time frame they need to renumber anyway, so why don't do it now? I know time. The third thing that we have seen is that especially on the West Coast, there are exchanges that have more or less shared layer 2 infrastructure and more or less shared IPv4 peering LAN structure, but for IPv6 they don't. And I've asked them why they do not have that, and they said, well, we don't want to. more or less political reasons, and I hope that this is being solved soon. But up to now, this prevents that the commercial carriers are having peering relationship in IPv6 with the research networks mostly. But I had a discussion yesterday, and there's some light at the end of the tunnel. People are willing to change that, and I hope that is going to be the case soon. So far for the exchanges, we have observed other technical problems during our rollout, and one of them were misconfigured tunnels. Like, this is especially the case when people just set up GRE tunnels and do not care about the payload MTU. And there are performance issues, like you do not get the proper throughput over the tunnel because of the wrong MTU settings. When the tunnel endpoints are using the automatic derived MTU from the egress interface, let's say, I've got an example here, stolen from Cisco. When two routers are terminating a tunnel, then and both of them are using as an egress interface something like E3, T3, or POS, then the MTU would be 4470, and then respectively for the tunnels a few bytes less. But this would assume that the entire path would rely on high bandwidth links with high MTUs. So if there's one hop in the middle of the two endpoints with just an MTU of 1500, then you face real problems with the throughput on the tunnel. There's fragmenting done, and often there's just ping traffic going over the link rather than production traffic. So we recommend that once people are setting up tunnels, that they're using fixed tunnel payload MTU settings, and this is done on both on Juniper and Cisco on the interface level with IPv6 MTU or IPv6 INET6 MTU, and these are the values for GRE tunnels or IPv6 IPv6 in v4, and it's probably a best practice thing to just verify that the tunnels are setting up correctly with the right values by pinging over the tunnel with the DF bit set. One other thing is we have seen is, I call it careless BGP. That is, some of the peers that we have seen do not care to have a local preference structure like in v4. They tag all, or they do not even tag their routes as customer, peer, or whatsoever route. They seem to have, for every route they receive a local preference of 100, which will result often in a non-connectivity, as I show you here. The next slide. Assuming that there's a customer C1 having a v6 prefix, and we assume that the customer is getting transit from T1 and T2. T1 and T2 are peering with each other, and we assume that T1 is getting upstream from T3 and T2 with T4. We, for now, assume that the customer doesn't prepend to T2. So that means that the propagation would be like this. The customer sends address to T1 and T2. Both are re-advertising their customer route to T3 and T4, and they peer with each other, so they have a backup path. So in that case, everything is working fine. But once the customer starts to prepend 2 or 3 times towards T2, then the things are a little bit changing. Then the propagation looks like this. C1 is announcing its routes to T1 non-prepended. T2 is seeing the route from C1 over the direct link prepended, but since they do not have a local preference, they use the route from T1 since it has a shorter AS path, but it is a peering route. So T2 doesn't re-advertise the customer route to T4 because they do not send peering routes to the upstream. But T1 is sending the customer link and the customer route up to T3, and there's a connectivity. But assuming that the link between T1 and T3 is failing, then T3 and T4 do not see the routes from C1 anywhere else. And the customer C1 does have the wrong assumption that he has a second upstream in case something goes wrong. So the behavior of T2 is actually more harmful than it is worth for the customer. Is this clear so far? I would say yes. Okay. Another thing we have seen is the misconfigured bogon filters or anti-bogon filters. We have seen that many people were filtering our allocation in the first days, and it took us the best of 3 months to get all that sorted, going to the ISP, say, listen, please fix your filters, and it was really ugly to get these things sorted. Some of the carriers were answering fast, some of them were not. And yeah, it was a real hassle. So else we have seen that there are de facto PI space reserved for root name servers or for internet exchanges or internet projects, which people are still filtering too strict and don't use the more specifics. So our assumption is don't filter too tight what you accept from your peers, but be tight what you accept from your customers. So acting liberally here is actually less harmful than acting strict. So we recommend to have a more relaxed set of filters applied. So far for free transit is an coin with two sides. Free transit is a good thing, where we have seen people giving free transit to other people when they help them getting bootstrapped, getting started with V6. There are some projects in Europe and US going on with that, which is a good thing. There's another good thing for free transit for strict backup links. So when people make sure that on free transit over an internet exchange or wherever, or even tunneled, is being set with prepends and a very low local preference, that is still a good thing. But what is not a good thing is when people are giving free transit away to other ISPs that have already native or tunneled V6 from their own transit, just to have more weight for their own peering relationship discussion and stuff like that. So we consider that really bad, and we have actually seen peers of us that announce us about 80, 70, 80, 90, 100 V6 routes from customers, and once we looked into it, then we have seen that only about 10 or 20 of these routes were from actual paying before customers. So the ratio is a little bit, so the ratio is a little bit strange. Then we have seen some miscellaneous, just operational annoying problems, which was the DNS IP6.ARPA to IP6 int, the other way around, and stuff like that. That is technology-wise not a real problem, but just from an operational point, annoying when you do trace routes and you do not have a proper reverse resolving. So this far from our things that we have seen. Once we go beyond the AS borders. We have found a few things to say on a conclusion. Of course, the vendors need to get their stuff sorted and should have proper IPv6 support in their software, and of course the hardware as well soon. Proper means non-different code bases for the same platform, and you cannot choose whatever you use. Then, of course, the IXPs should get their stuff sorted, going from non-production space to production space, and having V6 and V4 on the same VLAN. And of course, the tunnels, people should avoid transcontinental tunnels and stuff like that. For the peering relationships, we have found it is a good idea to find peers that have a proper local preference structure that supports communities, and all these things that we are used to have in the IPv4 world. And yeah, even if an ISP is peering with another carrier who is having a full route swap with someone else, it would be nice that when that certain ISP would offer communities that other people can steer whether they want to be announced to that full route swapper or not. So, and the very last thing I wanted to give you is pointers. There's, since a few weeks now, a very good IPv6 operational mailing list where most of the people I have seen in the V6 world are subscribed already, but in case you didn't know, this is a very good list and a good thing to have operational matter discussions. There are two projects, both in Europe and the States, are going on. In the States, it's the Arcade project. They are helping people to get bootstrapped with V6 until the ISPs get their stuff sorted and have native or tunneled IPv6 transit from their current IPv4 providers. And in Europe, it's the 6XS project. Thank you. And yeah, do you have any questions? Silence. Okay.
Actually, I think we've got time for maybe 2 questions.
I'm sorry. Yes, please.
Rüdiger Volk, Deutsche Telekom. Udo, well, okay, what you were telling about the filtering got me a little bit surprised.
Once again, please.
What you were telling about the filtering.
Yes.
If you are doing strict filtering for your customers, why would I, as your peer, need to be liberal about what I should be accepting from you? I would assume that your customers are registered in some database, and your own routes are registered there, and you can tell me precisely what term I have to look up in the database to get the precise filter, even for you as a peer.
This is correct mostly for the V4 world, but we have seen in the V6 world that many peers of us do not filter their customers anyway.
Well, well, okay, so
in V6.
Yes, well, in the V6 world seems to be a tiny, nice little place when you look at it from the V4's point of view and experience.
Of
and
course,
it's it's somewhat strange that well, okay, you people do not care to keep it clean as they start to grow. If within the small play world we don't get it right, we'll never get it right.
This is pretty much true, but you need to know that the registries started to offer Route 6 objects since December or January, so this automatic filtering mechanism is pretty new. Else the software, the IRR tools are just having support for Cisco's right or Cisco style configs right now. So you have to expand the software for the Juniper's NV6 for yourself. So there's no real tool support. Now, the tool support is pretty young in comparison to how long people are using V6 yet. So you have to give the people a little bit time to adopt to it, to use it, and to get their stuff sorted.
Okay, so the message should not be liberal, but ask your friends to do it right.
Indeed, yeah.
Dave Meyer. Sorry. I had a whole bunch of questions here, so I'll just pick one. You talked a lot about your address allocation strategy.
Yeah.
I was curious to know if you guys looked at anything like we're discussing on the PPML right now. Like, do you guys use an HD ratio, or how do you decide how you're going to do these assignments to your customers?
We're following the RIPE rules here, where the RIPE rules say any customer can have an /48 right away without doing some documentation. But we ask for documentation once they want more.
Oh, okay, okay.
So we assume every customer, we do not ask how many addresses do you need, we just say, okay, the RIPE rules give us the opportunity and the customer getting...
/48s.
Yeah,
Okay.
just straightforward.
Okay, I'll just leave it at that. Thanks.
Thank you very much.
Thank you.